Hello guys, welcome back to the Leetcode tutorial series. So in this video we'll be solving one more new question, trees binary tree question. So first let's get into the question. Count good nodes in a binary tree. So given a binary tree root, a node x in the tree is named good if in the path from the root to x there are no nodes with a value greater than x. Return the number of good nodes in a binary tree. Now let's have a look at the example. So here this is the binary tree. First example. So you are given a root node and you supposed to find the good nodes in this binary tree. For that they have specified the conditions to find the good nodes. So here you can see, let's take the one path 3 1. You can see the one node is the x node. This node, if it is greater than the previous nodes in the existing path, then this one is a good node, otherwise it is not a good node. So let's take one more path. This is a root node. So here 1 and 3, this is the x node, and 3 is greater than or equal to the previous max of the previous nodes. So 3 is greater than or equal to 3 comma 1. So then 3 is a good node. Now let's have a look at the right side of the tree. So here 3 4, this is one possible path. So here node 4 is the x. So this node x, I mean 4, is greater than the previous nodes in the path 3. So 4 is a good node. If we have a look at one more path 3 4 5, here node x is 5, I mean the last node in the path, you are supposed to check that value with the previous nodes in that path. So 5 is greater than or equal to 3 comma 4. Yes, that's true. So 5 is also a good node. Now let's take one negative flow. 3 4 1. So let's have a look at this path. So 1 is the x node. So 1 is greater than or equal to 3 comma 4. No, it's not. So 1 is not a good node. So only 3 3 4 5 are the good nodes, and here always root node is always a good node because root node is a one path. Now let's see how to solve this problem efficiently. So first things first I will be having one global variable to store the result. So that name is, I'm keeping it as a g. So initializing with 1, because root node always is a one existed path. So always the root node is greater than or equal to root node. So the output always, the minimum output is 1 always. Now let's start with the root node. Now we call the left side of the tree. Then we pass the root node, the current maximum node in that path, to the next node in that path that we are creating. So here you can see from root node we call the left side node 1, and we are comparing this 1 with this 3. So 1 is greater than or equal to 3? No, it's not. So 1 is not a good node, so you don't need to update the global variable. Now again call the leftmost part of the tree, then pass the value in the while moving further, just take a value from the previous maximum value from the previous path, then give it to the next node while calling recursively. So here you can see 3 is greater than or equal to 3. So update this global variable to the 2. Now again call the left side, then pass the max value as of now. So there are no nodes left. Just get back to the previous parent node. Now call the right side node, There is no there we don't have any existing nodes in the right side. Then like return back, then again return back, then return back to the root node. So in the left side we found two good nodes. One is this 3 and this 3. Now similarly we have to find it for the right side of this tree also, and make sure that like the value which we compare in every path is independent to different paths. So that's why we need to trace back the max value in the path in every recursive call. So next if we go to the right side, so we have a root node 4. So in this path 3 is the max, so we are passing 3 to the right recursive call. Now we will compare this 4 with 3. So 4 is greater than 3. So update the global variable 3. Now we found 3 good nodes as of now. Now again recursively call to the left side. Then pass 4, because in this path 3, 4, 1. 4 is the max one. So compare 1 with 4. 1 is not greater than 4. So just don't need to update the global variable. Then again these two nodes, there are no nodes. Then return back, return back, return back to the parent node. Now again call the right side of this part 5, pass the 4th in this path 3, 3, 4, 5. So here 4 is the max till this end. So now check 5 and 4. So 5 is greater than 4. So update the global variable. So now as of now we found the 4 good nodes. Now check again left side 5, 5. There are no nodes. So just return back to the parent node, again return back. Now we traversed the entire binary tree and we got the 4 good nodes. So this is how we approach to the solution. Now coming to the time complexity of this solution, we traverse through every node in a binary tree, so it will be O of n. We visit every node in the tree. Then coming to the space, we do the recursive calls. So we store every recursive call information in the stack. So the length of the stack will be O of h. So h is basically height of the binary tree. Okay, now let's write code in Python first. So what I will do is, in this video I will show you two different ways of writing code using recursion. So in Python I will follow one different way of writing, and in Java different way of writing, like solving this problem. So at the end of this video you can learn, get to know like this approach also we can do, like this way also we can use this recursive. So it's all up to you. You can use whatever, like which are you comfortable of using the way of method. Okay, so first I will be creating one global variable, df init self dot result equal to 1. Now let's start the main code. So if not root, return 0. Then next you need to split the tree into two parts, one left part, one right part. So for that I will create the one helper function, helper, which self comma, which will take the node as well as the value. Now here we check for conditions. If not node, return if node dot val is greater than or equal to n, then we need to update the global variable result as well as the maximum value in that path. So now we found a good node, so make sure just update the result as well as the update the value equal to node dot val, so that you can pass this updated value in the further recursive calls. So just call self dot helper node dot write comma value, then self dot helper node dot sorry, left right comma value. So in the end return, like once you're done in the left and right subtrees. Now here you need to call the helper functions, helper node dot left. So here what I was doing is I was uh, finding the good nodes independently, left subtree and right subtree. Like if you want, you can do it in a single helper function. You don't need to write again, like you don't need to separate. You can pass the root node and you can do the work. So it's up to you, like how you want to do the solution. So here node dot val self dot helper node dot write comma node dot val. Now finally return self dot result. So done, submit. Now let's write code in Java. So here we will do it differently. So first I will be creating one helper function, private int helper. So tree node and int val. So here if node equal to null, return 0. Next you need to capture the maximum value in the path, current going path, int max equal to math dot max. So node dot val comma val. Now return here. I will be writing, here is the main part, tricky part. So here I need to check whether the node x is greater than the values in the previous nodes in this current going path. I need to check and then call it recursively to the left side of the tree and right side of the tree. So for that I will be writing node dot val greater than or equal to val. If it is true, question mark, then we take 1, otherwise 0. Then call this helper function recursively. So helper node dot left comma and max value plus helper node dot right comma max. So we are done with the helper function. So it's very small code as compared to Python. Now just return helper root comma root dot val. Yeah, that's it for this video guys. Thank you. We will see you in the next video.